Okay, we left it on Friday here. We looked at the binomial theorem, okay, which was this long kind of formula that we're going to start looking at using for higher power polynomials. Okay, so the example that we looked at was 2x plus 1. We said the x and the y up here in the formula, okay, were just representative of the first term, second term. Okay, so down here you have x, or 2x is going to be your first term and 1 being your second term, so your y part of the formula. 5 was the n, so the power is n. You can see that as we go along in the formula. Okay. To get the coefficients, okay, we're using these. Okay, so each one of these get us the coefficient. Okay, and we should know what the word coefficient means. Okay, so the number in front of the variables. Okay, these all get us the coefficient of x. Okay, these are a calculator function. Okay, so on your calculator, if you press the button shift and the division, okay, you'll come across this NCR button. Okay, you should get if I was to go here, 5, choose 0. So in other words, if I have 5 things and I want to choose nothing from that 5, I've only got one way of doing it. So I put in 5, shift, division, which will get me a C, and 0. And that will get me an answer of 1. Okay, this one I'll put in 5, shift, division. I'll get that C and I'll choose 1. It'll get me an answer of 5. 5, choose 10. Sorry, 5, choose 2. Apologies. 5, choose 2 is 10. 5, choose 3 is 10. 5, choose 4 is 5. 5, choose 5 is 1. Okay, and we talked about that and what they mean a little bit more last Friday. Okay, so now we're looking at solving these coefficients first before I do anything else. So I've got 5, choose 0, I've got 1, and then I've got 2x to the power of 5 plus 5 times 2x to the power of 4 times 1 plus 10 by 2x cubed. Okay, and remember the cubed is outside the bracket. Okay, if you look up here, it's your x, the whole x term with the power. Okay, and our whole x term in this case is the 2x. So it's the whole term should be in the bracket, not just the x bit. So the indice needs to be on the full term. Okay, plus 10 times 2x squared times 1 cubed plus 5 times 2x to the power of 1, 1 to the power of 4, and lastly 1 times 1 to the power of 5. Okay, so these are my indices here now. Okay, or sorry, my coefficients, apologies. These are my coefficients, okay, to the x terms. Okay. Okay. So in the equation, again, we talked about this a bit more on Friday. We start out with just the first term to the full power of 5. And the first term starts to lower its indice each time. So I go from to the power of 5, to the power of 4, to the power of 3, to the power of 2, to the power of 1, to the power of 0. Okay. The y term, so the second term in the bracket, in the original bracket. So I'm talking about this one here. Okay, starts off at a power of 0. So in the first one, it doesn't exist. And you can again see that from here. And then we have y to the power of 1, to the power of 2, to the power of 3, to the power of 4, to the power of, and eventually up to the power of 5. So to the highest power. Okay, so the x term starts at a power of 5 and works all the way down. The y starts at a power of 0, or the second term starts at a power of 0 and works up to a power of 5. Okay, then we need to look at solving out the indices. So 1 times anything is just 1. So 2 to the power of 5, the indice goes, both on the 2 and on the x. Okay, so 2 to the power of 5 is 32. x to the power of 5 plus 5 times, always doing my indices first, the 4 goes on to the 2 and to the x. 2 to the power of 4 is 16, x to the power of 4, and anything multiplied by 1 is just 1, so I can leave that bit out. Plus 10, and I'm going to do my indices before I do any multiplication of the 10. 2 cubed is 8, x cubed, and again that will be multiplied by 2 squared is 1, or sorry, 1 squared is 1. Okay, so again, anything multiplied by 1 is itself. Then you've got 10 to the power of 4x squared, and 1 cubed is just 1. Okay. Then you've got 5 to the power of just 2x, and again 1 to the power of 4 is just 1. And the last one then, you've got 1 to the power of 5 is just 1. So solving my indices in that step, and then the last step is just the multiplication, okay, to get this final answer. So 32x to the power of 5 stays as it is. Then I have 5 times 16, so I've got 80 x to the power of 4, 80 x cubed, 40 x squared. 5 times 2 is 10x, and times 1 is still 10x, and the last one is just 1. Okay, and that is your final answer. Okay, to that question.